Hello dear friends, this is the simplest and easiest way of teaching learning process in our most favorite YouTube channel Physics Make It Simple by Dr. Rajendra Kobarne, now serving as a principal in Loknete Dr. Balasaheb V.K. Patil, Padma Bhushan awardee Pravara Rural Education Societies, Mahatma Phule Vidyalaya and Junior College, Dad Budruk Taluka, Rahata District, Ahmednagar. As long as 12 science oscillation is concerned, this is the lecture number 14, and in this lecture we want to discuss most interesting article, that is damped oscillation. What is damped oscillation? Damped oscillation is a periodic oscillation in which amplitude gradually goes on decreasing after the application of external force. Suppose the spring oscillates like this, then this is the amplitude of oscillation. As time goes on increasing, amplitude goes on decreasing like this, and such a oscillation is called as damped oscillation by the application of external force. Air resistance is acting on the spring or contact point between rigid support and spring reduces amplitude. Amplitude of oscillation gradually decreases. So this is the oscillation like this, and this is the amplitude of oscillation. This amplitude of oscillation slowly decreases with increase in time like this. Such a oscillation is called as damped oscillation, and the apparatus we call it as damped harmonic oscillator. So damped oscillation is a periodic oscillation gradually decreasing amplitude after the application of external force. We call it as damped oscillation, and here the oscillator is called as damped harmonic oscillator. So to study damped oscillation, I have drawn a simple diagram on the board where one end of the spring is connected to rigid support while another end of the spring is connected to a block of mass m. Then I have taken horizontal metal plate like this, and this horizontal metal plate is submerged into the liquid which is connected to the lower end of the block of mass m. This is the simplest experimental arrangement, and as long as the vertical oscillation is given, two forces are acting on the block. Listen carefully, very simple. Two forces are acting on the block. Restoring force Fs acting by the spring on the block. Restoring force Fs acting by the spring on the block, as well as damped force Fd acting by the horizontal metal plate on the block. Actually, that damped force Fd is acting by the liquid on the horizontal metal plate and then by the horizontal metal plate on the block like this. So two forces are acting on the block during oscillation, that is Fs, restoring force acting by the spring on the metal block, number one, and number two, damped force Fd acting by the horizontal metal plate on the block. So what is restoring force Fs? We know Fs is equal to minus Kx, where K is called as force constant and X is called as displacement of oscillation. So F is equal to minus Kx. It clearly indicates that restoring force and displacement are oppositely directed. Okay. In a similar manner, this damping force is exerted by the liquid on the metal plate, and that damping force is directly proportional to the velocity of the metal plate. It clearly indicates that larger the velocity, larger will be the damping force. As the metal plate moves in downward direction, damping force is acting on the upward direction. As the metal plate is moved in the upward direction, damping force is moved in the downward direction. That means velocity of the metal plate and damping force are oppositely directed, and that damping force Fd is directly proportional to velocity of the metal block, and so that we have written Fd is equal to minus Bv, where that B is called as damping constant, V is called as velocity of horizontal metal plate. Here also negative sign indicates that damping force and velocity are oppositely directed. Both the forces are having negative sign. So resultant force or total force acting on the metal, acting on the block of mass m, this block may be of metal, this block may be of glass, this block may be of any material of mass m. Two forces are acting on the block. I will repeat again. The first force is Fs, that is restoring force. Fs is equal to minus kx, and another is Fd, which is equal to minus Bv. So total force acting on the block is capital F, that I have written. Capital F is equal to minus Bv minus Kx, that I have written here. See here, minus Bv minus Kx. Fd plus Fs, what is the value of Fd? Which is equal to, the value of Fd is minus Bv, value of Fs is equal to minus Kx. Then after reshuffling this equation, we get what? F plus Bv plus Kx is equal to 0. So what is F? F is equal to m d2x by dt square. F is equal to ma, m into mass into acceleration. So acceleration will write is d2x by dt square plus b, the formula of velocity is dx by dt plus kx is equal to 0. This is the differential equation. This is the differential equation of damped oscillation. The solution of this equation is no need how that solution come. You will have to directly remember the formula that x is equal to capital A e to the power minus bt upon 2m cos of omega dash t plus phi, where this A e to the power minus bt upon 2m, this is called as amplitude of damped oscillation, and from that angular frequency omega dash, which is also equal to that formula, you should remember it. No need how it comes, only remember this formula. Angular frequency omega dash is equal to square root of k by m minus b upon 2m bracket square, and from that angular frequency we can write the formula of period, because we know period capital T is equal to 2 pi upon omega, 2 pi omega dash, sorry, not omega, 2 pi upon omega dash. Omega dash is equal to k by m minus b upon 2m bracket square, and from this we have to remember 3-4 formulae. This is the differential equation of damped oscillation. This is the solution of differential equation. X is equal to ae minus bt upon 2m cos of omega t omega dash t plus phi, where ae minus bt upon 2m we call it as amplitude of damped oscillation. Then omega dash, this formula is also we should remember. Omega dash is equal to square root of k by m minus b upon 2m bracket square, where period of oscillation capital T is equal to 2 pi upon omega dash. So capital T is equal to 2 pi upon square root of the value of omega dash is this. So remember the value of period, remember the value of omega dash, Remember the solution of differential equation, x is equal to ae minus bt upon 2m cos of omega dash t plus phi. And most important sentence we should remember it, the sentence is damping increases the period while decreases the amplitude. Amplitude decreases and period increases. So there may be a possibility of asking the question like this: damped oscillation number 1 decreases the period, increases the amplitude. B option, increases the period, decreases the amplitude. C option, decreases the period, decreases the amplitude. D option, increases the period, increases the amplitude. The correct answer is increases the period. In damped oscillation, period increases while amplitude decreases. So in damped oscillation किंवा damped oscillation we can say that increases the period, decreases the amplitude, like this. So this is all about damped oscillation. This is the graphical representation of damped oscillation. As long as time goes on increasing, amplitude of oscillation goes on decreasing, like this. After the application of external force, this is the graphical representation of damped oscillation. So this is the simplest and easiest article that I have discussed. Is take a screenshot, read it again and again. After taking a screenshot, listen it again and again, and be alert, remain to listen my channel Physics Make It Simple. Subscribe it and always remain in touch with the Physics Make It Simple. We will meet again by taking the next article. Goodbye.